So this problem number 4, we're not ready for until after we do the next section, which is 5.5, which is called use substitution. The answer is going to be C if you want to try to challenge yourself, but we can go over this one in the next work pack because this is really from the next section. For number 5, here we have to, this is really a free response, we have to evaluate 4 different values of f, and what we know is that f is the antiderivative of the graph we're given. So we're going to be using integrals to find these different function values. So for a, we need to look at what we know. F of 6 is 9, so everything is going to be involving an x value of 6 somehow. For f of 0, so we're interested in the x values of 0 and 6. So this is like the multiple choice questions and how we set it up. So the integral of f prime is going to be equal to f of 6 minus f of 0. And this is where we're going to have to evaluate the integral using area. So we don't want to forget that one way we can evaluate an integral is with area. So from 0 to 6, I am going up to here. So from 0 to 6, we're finding this area. Keep in mind that anything below the axis we need a negative value for. So negative 3 plus 7 minus 10 has to equal f of 6, which is 9, minus f of 0, which is what we're looking for. So this is going to give us negative 6 equals 9 minus f of 0. So f of 0 is going to be 15. If you follow that, you should pause this and try part B on your own. For part B, the answer is going to be 12. So if you got that, skip forward in the video and move on to the next problem. If you didn't get that, so if we're looking for f of 1, we're interested in the x values of 1 and 6. Again, it's 6 because we know that f of 6 is 9. Between these two values, when we set up a problem like this, we need to know one of these values on the right side over here. Since we're given f of 6, we need to make sure that we're working in terms of 6. Oops, I erased a little too much. So now we're only going from 1 to 6. So now we're starting here instead. So if we find the area, we have 7 minus 10 equals 9 minus f of 1. So negative 3 is 9 minus f of 1. So 12 is going to be f of 1. Okay, so if you followed that, pause the video, try to get C on your own. The answer to C is going to be 19. So f of 3 is what we're looking for. So we get that. We need the integral from 3 to 6. From 3 to 6, we're just taking this space in here. So I'm going to have negative 10 equals f of 6, 9 minus f of 3. So negative 19 is negative f of 3, and 19 is f of 3. Okay, so again, hit pause on this, try part D on your own. For part D, the answer is going to be 17. So now we have the integral from, we're going from 6 to 8. We just want the smaller number to be on the bottom of our integral. So now we're going from 6 to 8. 6 to 8, we just want this space in here, and we're told that the area of that space is 8. 8 is f of 8 minus 9, and 17 is f of 8. This next problem here is going to be a little bit different. So we have f is going to be, so we know that f of 2 is 3, and we're given the graph of f prime. So find f of negative 3 and f of 7. These are going to be set up in the same way as the last problem that we just walked through. So if you want to try them out on your own first, that would be a good thing to try. So just hit pause and give those a shot. The first part, f of negative 3, the answer is going to be 6.5. And the second part, f of 7, is going to be 2 pi plus 7.5. And to talk about how to do those, so f of negative 3, I'll do first. So we're going from negative 3 to 2 of f prime is going to be f of 2 minus f of negative 3. We know that f of 2 is 3. We're looking for f of negative 3. Now this side, to evaluate the integral from negative 3 to 2, I'm looking for this triangle plus this triangle. So that first triangle here from negative 3 to 1, so it's just a triangle, 1/2 base times height, is going to give us an area of negative 4. And then this little guy, 1/2 base times height, is 1/2. So I have negative 3.5 minus 3, negative 6.5 is negative f of negative 3, so that's how we get a positive 6.5. To do f of 7, so we need to go from 2 to 7. Again, we want the smaller number to be on the bottom. So this time we need to find the integral, we need to find the area between 2 and 7. So this whole space here, and this between, so I have a triangle over here, I have a rectangle, and then I have a semicircle. So to get this, the area first, the semicircle, so 1/2 pi r squared. The 1/2 is just because it's only a half circle. 1/2 pi r is 2. R is 2. And then we have plus, my rectangle is 4 by 1, so that's a 4. And then this little triangle here is just a 1/2. F of 7, f of 2 is 3, so f of 7 minus 3. So this is going to be 2 pi plus 4.5, and then plus 3 from the other side is going to give us that 7.5. Okay, so part B, we're looking for a tangent line. Remember, for a tangent line, you need a point and a slope. So we have the point is 2, 3. We do need the slope, which is going to be f prime of 2. We're looking at the graph of f prime. So f prime of 2 is just this point, 2, 1. We're looking at f prime. So f prime of 2 is 1, so our tangent line is just y minus 3 times, or sorry, y minus 3 equals 1 times x minus 2. And we can just leave it like that. We don't have to worry about simplifying. So the next two questions, you need to remember that you're looking at the derivative of f. So see if you remember how to find increasing and concave up. Hopefully we remember increasing. Concave up is a little bit more obscure, but see if you can answer these questions on your own. The answer to C is going to be from 1 to 7, and the answer to D is from -1 to 4. So if you got those, you can close out this video, you're all set. If you didn't, we need to remember f is going to be increasing wherever the derivative is positive. The derivative, we're looking at the derivative, so it's positive wherever it's above the x-axis. So it's positive from 1 to 7, so that's going to be our answer. And we would justify by saying because f prime is positive. For part D, we need to remember that if we're looking at the graph of a derivative, the function is going to be concave up wherever our derivative is increasing. We're increasing here and we're increasing here. So up until the top of this semicircle, our graph is increasing. So we're increasing, this is -1, and then this x value is 4. So we're increasing from -1 to 4. And that's what we would say, because f prime is increasing.